Yeah,
There
good
we
morning.
go. Now you can hear me. How are you?
I'm fine, thanks.
Where are you connecting from?
Nowadays, I'm in Georgia.
Okay, okay. All right. So it's like the afternoon, more or less.
Yeah, it's like
Good,
noon.
good, good, good.
Okay. Hello, everyone. Thanks for joining this workshop about ML.NET and machine learning. And give me just give me a second, please. I'll start my presentation. No, sorry. Yeah. Okay. My name is Denis. I'm a software engineer with over 17 years of experience in the field. I spent a considerable part of my career developing various security systems, but for the past 5 years, I've been immersed in the world of game development, and I believe that machine learning has the potential to help us create better games. Machine learning is not just about being on the cutting edge of technology. It's about understanding the tools that are shaping our world today. We live in the age of data. Every second, we're generating an immense amount of it, and machine learning is the tool that allows us to understand this data. Moreover, there is a demand in the job market for those with ML skills. We see that this trend is starting to increase, and I believe it will continue strongly into the future. I would like to add that using machine learning is much easier than you might think. Today, we will understand what machine learning is and how you can easily start using it with ML.net. Okay, today we'll begin with explanation of what machine learning is and where it can be applied. Next, we'll briefly turn our attention to .NET, discussing the benefits you can reap by studying and using this platform. After that, we'll introduce ML.NET, a comprehensive framework that brings the power of machine learning into the .NET environment. Lastly, we'll showcase a practical demonstration of ML.NET in action. Through this, you'll get to experience firsthand how ML.NET can be easily utilized to address real-world machine learning challenges. Machine learning is a powerful subset of artificial intelligence. In simple terms, it's about training machines to learn from experience and make decisions to or predictions based on that learned knowledge without the need for explicit programming. The process of machine learning involves several key steps. Starting with data input, we then prepare the data to make it suitable for the ML model. The model is then trained on this data, evaluated for accuracy and performance, and finally deployed to perform practical tasks. Data is the key to machine learning. It's the information has feeds our models, and the quality and quantity of this data can significantly influence the model's performance and accuracy. Therefore, it's crucial to ensure that we're using high quality, relevant data when training our ML models. And machine learning can be broadly classified into four categories: supervised, unsupervised, semi-supervised, and reinforcement learning. Understanding each type will help you in the future to understand exactly what you need. Let's talk about each type in more detail. Supervised learning is one of the most common types of machine learning. It involves training a model using a data set where the correct answers or labels are known. The model learns from this data, understanding the relationship between the inputs and outputs. Once trained, the model can be used to predict the outputs for new unseen data. This is particularly useful in a variety of real-world applications. For instance, in email spam classification, a model can be trained on emails that have already been labeled as spam or not spam. It learns from these labels to classify new emails correctly. Similarly, in credit card fraud detection, models can be trained to identify fraudulent transactions based on past transaction data. Image recognition is another great example of supervised learning. Models can be trained to recognize and label different objects in images based on previously labeled image data. Next is unsupervised learning. It is a fascinating type of machine learning. Unlike supervised learning, the model is not provided with any correct answers or labels during the training phase. Instead, the model must discover patterns, relationships, and structures within the data all on its own. Unsupervised learning has several real-world applications. For instance, it's commonly used in customer segmentation, where businesses group customers based on various factors like purchasing behavior, demographic, and more. Anomaly detection is another important application of unsupervised learning. For example, it can be used to identify anomalous network traffic and detect potential threats in its security. Semi-supervised learning combines elements of both supervised and unsupervised learning. The model is trained on a partially labeled data set. This means that some of the data points have known outcomes or labels, while others do not. The model learns from the labeled data and applies that knowledge to make predictions for the unlabeled data. Semi-supervised learning has found utility in several applications. For example, in image classification, it's often the case that we have a small number of labeled images and a large number of unlabeled ones. In such cases, the model can learn features from the labeled images and predict labels for the unlabeled ones. Similarly, in speech analysis, when only a small portion of speech data is transcribed, semi-supervised learning can be used to predict transcriptions for the rest of the data. Another application is in web page classification. If only some of web page are labeled with their categories, semi-supervised learning can help predict categories for the rest of the page. And the last one is reinforcement learning. It is a unique kind of machine learning where an agent learns to make decisions based on the feedback it gets from its actions. The agent interacts with an environment, takes actions, and gets rewards and penalties. Over time, it learns to make actions that maximize the overall reward. There are many practical applications of reinforcement learning. For example, it can be used to autonomous driving. The model, acting as an agent, learns to drive by interacting with a simulated environment and receive feedback based on its action. Reinforcement learning is also frequently used in game playing. Models can be trained to play games like chess and Go. Now, it's gradually coming to video games. The model learns the rule and strategy by playing the game repeatedly and learning from the outcomes. In robotics, reinforcement learning is often used to train a robot to navigate through a specific environment. The robot learns from its own mistakes and successes, gradually improving its ability to navigate effectively. And yeah, just give me just a second and we will continue. Yeah, thanks. Let me tell you a few words about .NET. It is a powerful tool that is free, open source, and supports the creation of a wide range of application types. This includes everything from web to mobile to traditional Windows-based application and even video games. There are several reasons to consider studying and using .NET. With .NET, you're not restricted to one kind of application or platform. This means you can use .NET to create diverse applications, whether you're developing a complex web application or an immersive video game. In today's world, .NET is used widely across industries. Its support for multiple languages and strong enterprise-level application capabilities make it a popular choice for many organizations. The game industry is no exception. For example, Unity allows you to create games with C Sharp. With the introduction of ML.NET, this platform has also opened doors for developers in the field of machine learning, providing them with tools and libraries to build ML models using their .NET skills. Before we move to the demonstration of how to use ML.NET, let's take a moment to learn a little more about this powerful framework and what it can offer us. ML.NET is a cross-platform open source machine learning framework developed by Microsoft. It is designed for .NET developers, enabling them to create custom machine learning models using familiar languages such as C Sharp or F Sharp without needing extensive knowledge of machine learning. It was first introduced in 2018 and has since been regularly updated and improved, making it a robust and a comprehensive tool for machine learning tasks. ML.NET isn't just for experienced data scientists. It's also aimed at .NET developers who are new to machine learning. Even beginners can start building ML models with relative ease. Furthermore, Furthermore, with ML.NET allows while ML.NET allows developers to craft their own machine learning models from scratch, it also supports the use of pre-built models. This means that if there is an existing model that fits your needs, you can incorporate it into your project with ease. This flexibility makes ML.NET a powerful tool for developers looking to leverage machine learning in their application. ML.NET is built with .NET developers in mind. It integrates smoothly with the .NET ecosystem. It empowers you to leverage your existing .NET knowledge, skills, code, and libraries. This means you can transition into machine learning more easily using tools and languages you are already familiar with. With With ML.NET, creating custom machine learning models is easier than ever. The platform provides tools like Model Builder, which offers a user-friendly interface. These tools utilize the power of automated machine learning or AutoML. This is a cutting-edge technology that automates the model building process, allowing you to focus on what you do best, developing great applications. With AutoML, all you need to do is load your prepared data. From these, AutoML takes care of the rest, automatically selecting the best performing models for your specific machine learning scenario. This makes ML.NET not only a powerful tool, but also a convenient and efficient one for .NET developers looking to incorporate machine learning into their applications. One of the key strengths of ML.NET is its extensibility. It's designed to be a platform which can work in tandem with other popular machine learning frameworks. This includes TensorFlow, Onyx, Info.NET, and others. The benefits of these access to a wide range of machine learning scenarios. You're not limited to the capabilities inherent from ML.NET alone. By integrating with these other frameworks, you can tackle more complex scenarios like object detection. And ML.NET not only offers ease to use, but it also delivers in terms of performance and accuracy. To illustrate this, consider a benchmark example where a 9 GB Amazon review dataset was used to train a sentiment analysis model. ML.NET achieved a 95% accuracy, while other popular machine learning frameworks couldn't even process the entire data set due to memory errors. But that's not all. When training was conducted on just 10% of the data set, in order to allow other frameworks to complete the training process, ML.NET still demonstrated superior speed and accuracy. This high performance is not limited to sentiment analysis. Similar results have been found in other machine learning scenarios, such as click-through rate prediction and flight delay predictions. This is a testament to the high performance capability of ML.NET. And let's take a quick overview to getting started with ML.NET in your .NET application. So I have a sample console application. In this example, I'll show you how to create and train a model which does sentiment analysis. And let me switch my demonstration. Okay, just 1 minute. Okay, this is a sample console application, but you can use it in any of your applications like web API or web application for your needs. I use that console application just as example to show how to easily you can introduce machine learning in your project with .NET and ML.NET. And firstly, what you need is get your ML model. If you already have some models, you can get it. But for that examples, we don't have ready to use machine learning models. And I'll show you how to easily create and train new model. To do that, I'll right click on project and add machine learning model in my Visual Studio. I just call it a model example. And now we on the model builder screen. A model builder is a powerful tool that helps you easily create your own model for your particular needs. In that example, I'll show you how to train model for sentiment analysis, and you can use it, for example, for your project if you have some website and where customers can leave their comments. You can use machine learning to automatically analyze how many positive and negative commands you have for some content. For that purpose, I'll choose data classification because I want my model to detect commands from customers. And the next step, we have to choose what power will used to train your model. For that example, I'll have on one option local CPU, but if you have a special environment, you also can use the power of your GPU, or you can train your model in cloud. And the next step, you can feed the data for your model. If you have SQL server already have it, you can use that option. Or if you have prepaid data in files, you can use file. And I already have some prepaid data. It is a simple data. It's used only for demonstrations ability of machine learning. And that file contains different comments. And we see it in the first column, and in the second column we have labels. 0 means that it is negative comments, and 1 means positive comments. I can show you how that file looks. It is just small file with small data, and we have some prepaid data in that. Okay, and I'll choose the column to predict labels. Of course, for my case, it is the column 1. Because in column 0, we have the data, we have comments. And it is pretty simple data. Of course, I use it only to show you how easily to use machine learning in your applications. And of course, training that simple data will take only 10 seconds, or I can set 20 seconds. But usually the big data set can take hours actually, but it gives more accuracy and performance. And now we see how ML Builder select different models to different type of models and choose the best one for your needs. But as I said, they were only 20 seconds, and of course, in real life, it is not enough. You have in real life and in real projects, you have uh, to prepare bigger data set, and it will spend more times, of course. And now we just can test test the model. For example, a good case, excellent value, and yeah, we just test it, and yeah, the result is for that comment, model said that it is a positive comment. And next step, we should, and at the next step, we should add the code to our project. For example, we can automatically add it for web API application or console app, but I already have console application, and I just copy code snippet for my needs. And there is a simple hello world application, and I decided to write a simple application that will receive comments and analyze that comments, just for example. And yeah, I will write a program that receive comments and it will stop if we put empty comment. While it is not empty, we will continue to predict. The program will continue to predict our comments. We have trained model, and I named it just a model, but of course, if you have big project, you have to choose some particular name, and it will predict our comment, and then it write the result. We have the result, and wait. predicted label. Yeah, what that result predicted, and if it is one for us, it will be a positive comment. Otherwise, it will be a negative one. Okay. And can you see that? Yeah, looks like. And yeah, that's all. I'll train the model, and I've trained the model, and I integrated in my application. In that case, it is pretty simple application, but of course, you can use it whenever you want and just test it. Of course, as I said before, it is not real. That model is not doesn't have pretty good accuracy, because the data was pretty simple, and uh, we were training it very short time. But why not? We'll just try. It is, what if someone leave that someone leaves that comment, it is good. And yeah, our trained model said that it is positive comment. But for example, maybe try it doesn't look good. Doesn't look good. No, it is still think that it is positive, but yeah, of course, because it is a mistake. Yeah, for it is bad if it decided that it is negative comments. So that's that all what I wanted to show you, and thank you very much for visiting that workshop, and maybe you have some question about it. Yeah, I would happy to answer. I would happy to answer you if you have some questions. Yeah, and yeah, if there is no questions, thank you again. Thank you very much, and I hope you will decided to use ML, or you decided to start you will decide to start using machine learning in your project. And I don't know what platform do you use now, but if you're looking for something, I think that .NET is a pretty good case for starting, and a pretty good platform to dive into it, and yeah, and get good performance. Yeah, yeah, of course. And thank you very much, and yeah, bye.